All right, so good morning, everyone. I welcome you back into today's class. And before we move into what we have for the day, please help me to verify if you are hearing me clearly.
I can hear you clearly. Good morning.
All right, so good morning, everyone. Okay, so with no more delay, let's move into what we have for today. In our last class, we were able to focus on the first chapter of this particular course. So in today, we're going to be starting from understanding TCP/IP. So we need to know what TCP/IP is and how TCP/IP works. So when we're talking about TCP/IP, TCP/IP stands from a transmission control protocol slash internet protocol. So these two protocol here, they work together before they can achieve their aim on the network aspect. Anytime that we have a TCP without IP, the TCP is going to be useless. And if you have IP without TCP, IP as well is going to be useless. So it's just like when you have a mobile phone and a SIM card. So mobile phone and SIM card, they work together before everything can be moving smoothly. Imagine that you have a SIM card without you having a mobile phone. The SIM card is going to be useless. And imagine you have a mobile phone without having SIM card. The mobile phone as well going to be useless. So that's how the TCP IP works. So before the TCP IP can work, they come together before they can work perfectly on the network. So let's now see how this guy works on network. So here it says TCP IP stands from Transmission Control Protocol slash Internet Protocol and is a suite of communication protocol used to interconnect network devices in private and as well on the internet. So before a two system can communicate on a network, they make use of TCP IP. So for example, if I make use of my system to share some data to your system, before your system can get that data, is making use of TCP IP. So that TCP IP is just like a rules, a set of rules, a set of policy that guide how systems communicate to themselves, both on the LAN or on the internet. So when we're talking about this TCP IP here, this TCP IP has two versions. So we have two available versions inside this TCP IP. The first version is TCP IP version 4 and the second version is TCP IP version 6. So we need to put that in mind. TCP IP has two available versions, both version 4 and version 6. So this TCP IP we're talking about, this guy was developed by the US Department of Defense, which is the DoD. This guy was developed by DoD, Department of Defense, to specify how computer transfer data from one device to another. So before a system can communicate, they make use of TCP/IP. So this TCP/IP that they are making use is developed by who? Is developed by United States Department of Defense. So let's try to break down how this TCP/IP work in a easier way. So here says TCP manage how a message is assembled into smaller packets before they are then transmitted over the internet and reassembled in right order at the destination address. So I'm going to be using this whiteboard here to explain how this TCP works. So for example, let's assume that I have a system here. Maybe here is a system. I have a system and I have another system here. Maybe this guy is connected to themselves. So maybe there is a files of 20 gig. Let's assume that there's a files of 20 gig.
Sorry,
Okay.
Mr. Sam. I
Yes.
think there's something wrong with your screen. Like,
Okay, you're not seeing the screen.
yes.
Okay, I'm coming. Let me solve that one before. Let me solve the issue first. So please hold on, let me solve the issue of this screen before we move on. Please, are you seeing it now? Let me check if you are able to see the screen.
Only your mouse is moving, but the main screen is blank.
Okay.
Everything is okay now.
I think is the I think is the Zoom, but I need to open it in another place and check something first. Okay, so let me open it here. I will remove this. Okay, so let's go back into what we're doing. So I already explained to you that TCP/IP manage how system communicates on the network. So let me break down the function of the TCP and the function of the IP. So for example, let's assume that we have a two system on the network. When we're talking about network, there must be a sender, and there must be a receiver. So let's assume that this sender needs to send a file worth 20 gig to this guy. Maybe this guy here needs to send a file worth 20 gig to the receiver. That price of that 20 gig is not just going to move directly to this particular receiver. No, the file is not going to move directly. It's the function of TCP to break down this 20 gig into what we call segments. So is it TCP going to segment that file in a way that we can have like 50 MB, can have 50 MB, 50 MB, 50 MB. So TCP will break it down into smaller particle. So when TCP break it down, it's the function of IP to make sure that this particular file here move from the sender and go successful to the destination. So when the file needs to enter the destination system, is the function of the TCP that break it down before. It will be the ones to rearrange it back into something that the receiver going to understand. So that's how TCP IP works. So before anybody can communicate on the network, they make use of TCP IP. So TCP going to break down the packet, and when it break down the packet, when the IP transfer the information from one end to another, is the function of the TCP to make sure that it reassemble the packet back into what it is before. So here says TCP manage how a message is assembled into smaller packets before they are then transmitted over the internet and reassemble it in the right order at the destination address. Okay, so what's the function of IP? IP define how to address and route each packet to make sure that it reach the right destination. So the function of IP is to make sure that the information sending from the one system to another gets to the system successful. It's not maybe I want to send information to computer A and at the end of the day, it is computer D that is receiving the information. No, IP address going to make sure that the information gets to the right destination. So that's how these two guys work. So before we can have a smooth communication on the network, we'll make use of a TCP IP. So here says an IP address, which stands from Internet Protocol Address. This address here is a series of numbers that are assigned to each devices connected to a computer network or the internet. So before any system can communicate on a network, they make use of an IP address. So for the first place that we're building up a network, we need to assign a unique IP to each system on the network. Just like when we give birth to a child, the next thing is to name the child, give the child a name. The same thing with that particular IP address. The name we give to system is what we call IP address. That IP address is what all those systems use to communicate to one another. So here says an IP address identify and differentiate the billions of online devices, including computers, mobile phones, and help those devices communicate with one another. Like what I just explained, before all these systems can communicate to themselves, they make use of an IP address. So for instance, if I open my browser and I type www.facebook.com, before I can have access to Facebook website, my system is making use of IP address, and the Facebook as well is making use of IP address. So that's the reason why anytime you type facebook.com, you will be able to land on their website. So you cannot type facebook.com and you are landing on Instagram, except you are now under attack. But the function of IP address to make sure that each computer on the internet are able to communicate to one another. So here says other devices connected to the internet, including printers. Printers make use of IP address. Growing number of Internet of Things, like a smart speaker. A smart speaker using IP address. What about a refrigerators, home surveillance system, and more? A smart TV. All those guys, they make use of IP address before they can communicate. So anything that we call a network devices, before they are able to communicate to one another, they make use of what we call an IP address. So TCP IP is very, very important when we're talking about network aspects. So when we're talking about this IP, let's see what this IP address looks like. Here says example of IP address of various devices connected to a same network. So here says every system IP address must be unique. So when we're talking about this IP address, any IP that you give computer A, you cannot assign the IP to computer B, because each system on the network need their own unique IP address. So inside this diagram here, you're going to see that we have like 5 devices. The first device is having an IP address called 172.16.254.1. That's the IP address of the first computer. The second computer has 172.16.254.2. That is the second IP. The third computer has 172.16.254.3. Next one get 4, another one get 5. So if you see all these IP, you're going to see that the IP are unique IP. It is not maybe we assign the same IP of this 254.1 to all of them. No. Each system on the network must have their own unique IP address. If you can see here says in the diagram below, network is 172.16.254.0. There is a difference between a network address from IP address. So when we're talking about a network address, it is inside a network address we're going to be seeing IP address. So network address give birth to IP address. Network address gave birth to IP address. If you see this place here, says the network is the combination of the entire system on that particular network. So whenever you combine all the IP address together, we know it as their network. But it is inside that network you're going to be seeing this different IP address. Like here, when you're talking about 172.16.254.0, this is a network. So how many IP can we see in a network? We can see 254 IP inside a network. We can see 254 IP inside a network. What does that mean? It means that the first IP inside this network will be 172.16.254.1, which is what we give this first system. The second IP will be 172.254.2. So these three number here will be the same thing. It is the only zero that will be changing from 1, 2, 3, 4 to 254. That's how a network is. If you check all the IP address of this system here, the three number is the same thing on all the IP. It is only the last digit that is changing from 1, 2, 3, 4, 5. So anytime you see IP address of different system and the three number is the same, that means that all those systems, they are on the same network. And any system that they are on the same network, they will be able to communicate to themselves. So just put it in mind, anytime you see an IP address added with 0, that is what they call a network address. And how many IP can we see inside a network address? We can see 254 IP address inside a network address. It means that this IP you see here going to be ended at 172.16.254.254. Those are the IP. Here now says Why do we need IP address? The reason why we need IP address here is that computer need IP address to communicate with other online devices and network. The purpose of IP addresses is to map the web and send data to the right places. So this IP address is very, very important when we're talking about the networking aspect, because before system can communicate to one another, they make use of an IP address. Just like human being, before I can see someone and I say I want to communicate to you, I need to know wherever your name is. If I don't know your name, it's going to actually difficult for me to say I want to communicate with you. But with this name, I can call you with your name and we're going to be able to interact. The same thing with this particular IP. Before anybody on the network can communicate to another devices, we're making use of that particular device's IP. Just like imagine that you want to send some goods to another location, and you are making use of a dispatch rider. You need to give the dispatch rider the street, the destination street, and the number where it's going to deliver that goods. The same way the IP address works. So it means that if the dispatch rider doesn't have the right street, the right number, it might ending up sending the goods to a wrong places. So with the right destination street, the dispatch rider will be able to deliver the goods to the appropriate place. The same way the IP address works. So if system doesn't have IP address, no way all those systems can communicate to themselves. So here you're going to see some diagram here. Before you are able to browse to facebook.com, you are making use of IP address. Before you are able to check your mail to see your mail, you are making use of IP address. Before you are able to surf the internet, you are browsing the internet, you are making use of an IP address. Yes, yes, you need an IP address to use social media, check your mail, and browse the internet. So anytime you don't have an IP, you are not going to be able to communicate to all those websites. Okay, so this IP that we are talking about, we actually have different types of this IP address. We have different types of this IP address. The first type of this IP address is what we call public IP address. The first type of the IP address is what we know as a public address, and the second type is a private address. So let's try to know the difference between this public address and the private address, and let's try to see where you make use of all these addresses. So when we're talking about a public address, as the name called public, this called an external or global IP address is used to communicate between hosts and the global internet. So anytime that we have a computer, maybe we have a group of employee and all those employee needs to browse to the internet, they need to communicate to some hosts over the internet, they need what we call a public address. So anytime you bring up your phone, you are browsing to internet, you are making use of WhatsApp, you are making use of Facebook, the IP you are using that time is what we call a public IP address. So before you can able to solve the internet, you are browsing to the internet, you are making use of a public IP. So here it says public IP addresses are provided by ISP, which is what we call an internet service provider. So before you can get a public IP address, all those IP address is given to you by ISP. In which way? Imagine I have a phone now. If I need internet on this phone, it means that I need to go and purchase a SIM. Either I'm using MTN SIM or I'm using Airtel SIM. So for those people that are in Nigeria, the ISP that we have in Nigeria here are MTN, Airtel, Etisalat. So it means that before I can have internet on my phone, I must have already get one of those ISP SIM, BU, MTN, or Glo. So when I have the SIM, I need to subscribe to a data plan before all those ISP going to give me a public IP before I can browse the internet. Okay, so just put it in mind when we're talking about a public IP address, those are the address that we use to communicate to the host over the internet. the IP that we use to browse the internet. Those IP are what we call public IP address. And this IP can only be given to you by the ISP, which is an internet service provider. Okay, so the second type of the IP address are what we call private IP address. A private IP address, often called a local or internal IP address, is assigned to your devices from within a private network. So when we're talking about private IP address are the address that we use within our local area network. So anytime we have a LAN and we don't need internet, the IP we use for a local network are what we call private IP address. So it says private IP address are not routed on the internet and are intended to work only within your local network. So anytime you have an IP called private IP address, no way you can browse the internet. You are not going to have internet access because the IP only work for a local network. It work within your inner network. The IP cannot go to the public network. So make sure you put the points in mind. We have two types of IP, both public and private. Public IP are the IP we use over the internet, while private IP are the IP we use within our LAN. Okay, so when we're talking about all these type of this IP, let's assume that we have any IP. Next thing is for us to learn how we can assign the IP into our system. So maybe you get a public IP or you got a private IP. How do you give the IPs to your system? We can assign IPs to our devices in two ways. The first way is a static IP and the second way is a dynamic IP. We can assign IP address to our devices in two ways. First way are static IP and second way are dynamic IP. Okay, so before I move on, I hope you guys are hearing me clearly. I hope you guys are hearing me so that I'm not going to.
Yes, I'm
Yeah,
hearing
I
you.
hear you.
Okay. So we have two ways that we can assign IPs to our devices, be you both private or public. We can assign all those IPs to our devices in two ways. The first way, you can actually assign it either you are making use of a static way or you are making use of dynamic way. So when we're talking about static way of assigning IP, what does that mean? Here it says a static IP address is an IP address that is manually configured on a devices by the network administrator. So anytime I come to my system, it means that I'm the one that come to my system and I give the system the IP. Any IP that you are giving the system by yourself, those IP are what we call static IP. Here now says when a device is assigned a static IP, the IP address won't change over time, which can help some online service work more smoothly. So anytime I assign IP address to a devices in static way, that IP address cannot change. That is what the device is going to be using, except you go into the devices and you change it into something else. So a static IP address are the IP address that is manually assigned to a devices by the network administrator. And anytime that we give a system IP address with static, it means that that IP cannot change. That is what the device is going to be using forever until the administrator go there and change it back. So the second way of assigning IP is dynamic. This dynamic way here is an automatic way. So here says a dynamic IP address is an IP address that is automatically assigned to devices on the network by who we call a DHCP. So a DHCP is what we use to assign the IP automatic to all those clients. So DHCP here stands from Dynamic Host Configuration Protocol. So this DHCP here will act as a server that's going to be assigning the IP automatically to all those systems. So anytime we are using static, we are the one going to the system manually. But anytime you are using dynamic, the system getting IP automatically from who? From what we call DHCP server. So here says a dynamic IP address can change when it needs to, such as when a device is connecting to a new network. So anytime you put your devices on dynamic IP and your system getting IP automatically, the IP that the system is getting on that dynamic, it can only work for some certain period of time. That IP cannot be used for a long time because IP on DHCP do use to change when the time needs to. Because anytime you are configuring this DHCP, there is what we call a lease time. Lease time here stands from expiry day. It means that if I configure a DHCP and I use the lease time as a 2 days, so if I configure the lease time as 2 days, it means that any system getting IP on the DHCP, they can only use that IP for only 2 days. So in the next day, second day, the server going to collect the IP, and anytime the system requesting a new one, the IP going to be changing. So just put it in mind, with a dynamic IP, the IP address used to change when the time comes. But with a static IP address cannot change except you go there yourself and you edit it into something else. Okay, so all those things are the two ways that we can assign IP address to our devices. Either you are using both static or you are using dynamic. And put it in mind, I explained to you that we have the two type of this IP, BU public and private. Public IP is used over the internet and it can be acquired by ISP, and private IP is used within our LAN. Okay, so what I'm going to do right now here is to show you how we can configure these things, because here we are talking about static and dynamic. So what if you want to assign IP address to your system by yourself? How do you do it? What do you want to use dynamic? How do you do it? So I'm going to be showing you how you can do this too. After that, I'm going to show you how you can check whatever your PC IP address is. So please hang on a little bit. All right, so let's start from where we stop. Next thing I'm going to be showing right now here is how you can assign IP address to your system. Either you're making use of a static way or you are making use of a dynamic way. So how do we do it? The first thing here, I would like you to be going along with me. So the first thing you're going to do is to open your search. When you are in your search, you need to open your command prompt by typing CMD. So when you in the search for command prompt. When you see the command prompt, you open the command prompt. So, okay, when you are inside the command prompt, you're going to be making use of this command, which is what we call ncpa.cpl. So you're going
If
to
we
be,
are, excuse me, sir,
yeah.
if we are on a Mac, how do we proceed?
If you are in a Mac own is different. Mac, you need to go to the system, you will see settings, and you're going to see the network settings. That's where you're going to do for Mac. But this one here is window. Actually, best thing is to make sure maybe you're going to get a small window, because everything you're going to be doing here, we're going to be using Windows to be learning all those things. The best thing is to get, maybe you get a small Windows that we'll be using to participate in it, because the way you configure Windows different from the way you configured Mac. So for Mac, you head into the settings and you're going to see the network settings. That's where you're going to assign the IP. So for the window, head into the CMD and you type ncpa.cpl and you hit the enter key. Okay, so when you hit the enter key, you're going to see different adapter that you are using on your own system. You can see both Ethernet, Wi-Fi, Bluetooth. So anytime that you see all those things, if I'm using cable to connect the system together, it means you will be using Ethernet. Anytime you are using Wi-Fi, you will be using Wi-Fi. So let's assume that I want to assign IP on Ethernet. I double click on it. You double click on it. Once you double click, you come to properties. So when you come to properties, you're going to see TCP IPv4. Double click on it. So when you double click on the TCP IPv4, you're going to see that there's a two option here. The first option says obtain an IP address automatically. Anytime you are using this first option, it means that you want to use a dynamic IP address. The second one says use the following IP. Anytime you use the following IP, it means that you are using a static IP address. So put it in mind, anytime you put the system on obtain automatically, you are using dynamic. Anytime you use the following, you are using a static IP. So you are not going to be putting the IP that you want to use by yourself. For example, if I assign 192.168.100.1, that is the IP I'm giving this guy. But what if he wants to use automatic way? You will just click on it. But before you can use automatic IP, it means that there must be what we call a DHCP server. So there must be DHCP server before automatic IP can be working. So if there is no DHCP server and you put your system on automatic, it's not going to get in any IP. But if you want to give the system IP by yourself, you use the following IP and you're going to type whatever IP that you want to assign to that particular system. So that's how you give your system IP. Either you are using the first one, which is for dynamic, or you are using the second one, which is for static. So next thing I'm going to show you now is how to check your IP address. So how can we check whatever the IP address that our system is using? So before you can check your IP address, you need to be inside the CMD. So when you are in the CMD, just type this command ipconfig. Ipconfig here stands from Internet Protocol Configuration. For those people that they are using Mac here, you're going to type if config, which stand from interface configuration. For Windows, you type ipconfig, internet protocol configuration. We hit the enter key. Okay, so once you hit the enter key, you're going to see the IP address that my system is using. My system using 172.20.10.6. So you're going to check whatever your own IP address is and you are able to see it. So that's how you check whatever IP address you are using on your system. Head into the CMD and you type this command, which stands from ipconfig. So you'll be able to see the IP address. For those people using Mac, you type if config, you'll be able to see whatever the IP address. Okay, but this IP address you see here are what we call a private IP address. So these IP are private. So whatever you want to see your public IP address, you go to the internet. So if I open the internet and you type, what is my public IP? So if you go to the internet, you're going to see wherever your own public IP is that you are using over the internet. Okay, I hope there's no issue on you assigning IP and checking whatever your IP address is. Is there any issue regarding
Um,
that particular aspect?
yes, there is a small issue, and the issue is, I once learned about IP, and there's something they said about ports. Well, everything you've said there is just about an IP. We've never mentioned anything about ports. So does that mean that an IP can work without a port? That's one.
Okay, you mean
And
does an
that's
IP can work without a port number?
yes.
Yeah, actually, port number as well is very, very important. All those things work together. So IP cannot work without a port number because different services, each services that you are doing on the network has their own port number assigned to it. So anytime you are browsing the internet and you are using HTTPX, it means that you are using port number 443. So everything you do over the network use its own port number. But we are not going to be talking about port number here. We are still referring to IP address.
Okay. Another thing again, when you put the IPs and all of that, it looks like a demo. Can we do some, can, while you are talking about this whole beautiful theories, yeah, can we see you put in an IP like real time and make it do what you are saying while we see it?
Okay, I should give the system IP, right?
Yes, while we are
Um,
looking at it, like you assign an IP to a system and then you make it work and we see how you do it and how it works instead of just the plenty talk.
okay. So I already show you how you assign the IP. Actually, when you here, if I'm the CMD, I explain to you that you type ncpa.cpl. You come to you can see here that we have different adapter, like the one for virtual bus, the one for VM, and the Wi-Fi. So I'm using all these things. I cannot go ahead and change this IP on my Wi-Fi, so I leave it. So let's assume that I want to change IP on my virtual bus. I'll double click on it, comes to properties, going to see TCP IPv4. This guy was on automatic before. If I use a static, it means that I'm going to assign IP address myself. Let's assume that I assign 100.100.100.6 to this guy. When I assign the IP, I click OK and I click OK. You close. So when I come to my CMD, I type ipconfig to see wherever the IP address is. So you're going to see the IP I just assigned right away, which is 100 or 100 or 100 or 6. So that's how you give system IP with no issue.
One more thing. So does that mean that there is no specific sets of number combination that can be used to assign IP, like any number goes?
Yeah, we're still heading into where you're going to see the different ranges of IP. But here, we are just letting you know what the IP is and how you can assign it. So in the next two slide now, you're going to see the different ranges and you're going to see how the ranges work.
Thank you very much, sir.
Yeah, welcome. Okay, so next thing here is to see the different classes of these addresses that we have. So like I already explained to you, this TCP here has both version 4 and version 6. Actually, this version 4 here is the one that they use worldwide, is the one that is already common. Version 6 is not common the way version 4 is. So inside these classes of IPv4, we have different classes of IPv4 address. The first class is class A, second class is class B, third class is class C, fourth is class D down to class E. So those are the 5 classes of IPv4 address. Class A, class B, class C, class D, class E. So what are the ranges of IP can we see? The ranges of IP. Anytime you see an IP started from number 1 to 126, so that IP belongs to class A IP address. So anytime you see an IP address starting from 1 to 126, that IP belongs to class A IP address. And here says how many number of hosts. So when we're talking about hosts, hosts are the devices that we can assign IP address to. So anywhere you are hearing about host, host is any devices that can take IP. It can be a system, it can be server, it can be printer, it can be router, it can be switch. All those things are what we call host. So how many hosts can class A contain? A class A can only occupy like 16 million plus hosts. So it means that anytime that you are having like 20 million, class A cannot take it. Class A only take number of hosts of 16 million plus. So which scenario do we use class A IP? We make use of class A IP in a large network. So we make use of class A IP in a large network, just like all those ISP, like MTN. You can't imagine how many people MTN are signing IPs to a day. So all those guys are the ones that are using class A IP. So all these classes of IP has their own default subnet mask, their own follow come subnet mask. Any IP that falls inside class A their own default subnet mask is 255.0.0.0. That is the follow come subnet mask for any IP that belongs to class A or /8. So either you call it 255.0.0.0 or you call it /8. This thing is what we call a subnet mask, and this is what we call a CIDR value. CIDR value for this subnet mask is what we call /8. I'm still going to explain how they arrive at that /8. Just put it in mind, anytime you see any IP starting from 1 to 126, that IP falls inside class A. Just like when you see me assigning IPs to this my system, if I go back to this my system, I comes to properties, I come to TCP IP, you're going to see the IP I give this my system 100.100.100.6. So if I may ask you, this type of IP belongs to which classes of address? This 100 or 100 or 100 or 6, it belongs to which classes of IPv4 address? So this IP you are seeing here, 100.100.100.6. This IP belongs to which classes of IPv4 address? Which classes does it fall inside? Is it class A, class B, class C, class D, or E? 100.100 or 100.6?
It's class A.
So why do you say it's
Class
class
C.
A?
Because it's between 1 to 126.
Between?
It ranges between 1 to 126.
Okay, the ranges fall in between 1 to 126. Okay, so if I give you this one, let's assume that we have I'm coming. Let me give you another one. So I'm coming. So if I have something like this, if I have something like this, 100.192.192.7, which classes of IP address does this guy fall into?
A.
Class A. Why do you say it's class A?
Because the IP range from 1 to 126.
But here we're having 192 here, right?
Yes.
So which one do you use to determine the classes from all this number? Is it the first or which one?
The first.
Okay, it is the first that you are using to know the classes, right?
Yes.
Yeah, actually you are right. So anytime you see any IP address, you first check which first octet that you see. Any number of the first octet is going to determine which classes of the IP. So anytime you see an IP that is like this, for example, if you see 192.168.100.5, so you already know that this 192 here falls inside the ranges of class C. So you already know that this guy fall inside class C and these two fall
Buyer.
inside class A.
Buyer.
Okay, so that's how the other is. So anytime you see any IP ranges from 1 to 126, you know that that IP belongs to class A IP. So let's move into class B. Class B IP address starting from 128 and ended at 191. So any IP you see in the ranges of this number, it belongs to class B. And what are the number of hosts? How many devices can we assign class B IP address to? This class B IP address can only be assigned to 65,534 devices, and this guy is used in a medium network, just like bank. All those banks are the one that they use class B. And what are the subnet masks? The default subnet mask for class B is 225.225.0.0 or /16. which is the CIDR value of that particular subnet mask. I'm still going to explain how they arrive at all this slash. So for class C, the ranges of class C start from 192 to 223. So anytime you see any IP from this range, it belongs to class C. And what are the number of hosts? How many devices can we assign class C IP address to? We can only assign class C IP address to 254 devices. And this guy is used in a small network, just like a cafe. All those cafe, they make use of a class C. And the default subnet mask for this class C is 225.225.225.0, and the CIDR value for that subnet mask is /24. Actually, both class D and E, we cannot assign this IP address for devices. So all those guys is made for research. Anytime you want to do a multicast transmission or scientific research, they make use of these two guys. So, but from a normal networking aspect, we make use of class A, B, and C. Those guys are the IP that we use to assign to our system. So when we're talking about this 225.0.0.0 or /8, how did they come across this particular /8? So anytime that we have this 225, we have 225.0.0.0. So anytime that we convert 225 into binary, what are we going to see? Please, someone help us to convert 225 into binary. What are the digits that you're going to be seeing? If you're converting 225 into binary, what are the digits you're going to be seeing?
Zero one zero one one zero, something like that, right?
Do you know what binary is? Please, do we know what binary is, and do we know how to convert into binary?
Divide by 2. That is a 1 into 6.
Okay.
6 ones.
You say that 1 into 6 are 1, 2, 3, 4, 5, 6. That's the binary for 255.
1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8.
7, 8. Yes, this is the binary for 255. Binary for 255 is a 1 in 8 places. So if you do binary for a 0, you're going to see a 0 in 8 places. So you're going to see 0 in 8 places, 0 in 8 places. So how did they come across this one here, this 8 here? They only calculate that particular 8 ones that you have. If you calculate 255 into binary, you are going to see 1 in 8 places. So that's how they arrive at /8. What about this guy that they arrive at /16? 255 here will be 1 in 8 places plus another 255, which is another 8. 8 plus 8 give you 16. For the /24, they calculate 8 plus 8 plus 8 give us /24. So that's how they get all those /4 of all the subnet masks. So the CIDR value for a class A subnet mask is /8. CIDR value for class B subnet mask is /16, and the CIDR value for class C subnet mask is /24. All right, I'm listening to you.
Okay, so for range A, we have 1 to 126, and I can see that we don't have 127 because from the other one, we can see
Yes,
one.
that's a great observation. Actually, that 127 here, they omit it. It is meant for some purpose, which is what we call the loop back test. So we're still going to be talking about the function of that 127 when we come down here. But they omit it for some certain reason. That's why you are not seeing it here. Any other question, please?
No, thank you.
Okay, so all these things here are the different ranges for all these guys. So you already know the ranges and the number of hosts. Actually, sometimes it can actually be difficult for you to know how many number of hosts, but there's a formula that you can use to know that number of hosts. So there's a formula that you can use to know how many number of hosts. So for example, if I open this place, the formula to know this, I'm coming, let me open my word board. I don't think so. Okay, so the formula to know a number of hosts. So this formula here is 2 raised to power y minus 2. That is the formula. 2 raised to power y minus 2. What's this y? Y here is the number of the bits. So if I come back to this particular slide here, if you see our class C, how many subnet masks do we have for class C? Class C subnet mask here is a 255, 255.255.255.0. That is a class C subnet mask. So it means that at the end of the day, if you do the binary for this class C subnet mask, you're going to see the first 255 will be 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 0, 0 in 8 places as well. Because anytime you are doing binary for 0, you're going to see 0 in 8 places. So anytime you see 1, 1 is already network. 0 is what we call a bit. So it means that here we have a 0, 8, 8, 0. So if you come back here, so if I come back here, it will now be 2 raised to power 8 minus 2. 2 raised to power 8 minus 2. So someone please help me to check 2 raised to power 8 there. 2 raised to power 8, what's the answer? So we want to see how many number of hosts we can see in class C. We don't want to be using this one because actually it can be difficult for you to remember all these things. But we're going to be using this formula to remember all those things easily. The formula here is the 2 raised to power y minus 2. This y here is the number of the bits, the host bits that you have in the subnet mask. So we have 8 bits, which is 80. So we now say 2 raised to power 8 minus 2. 2 raised to power 8. So if I check, so 2 raised to power 8, no. So for
250,
example, what do you say?
256.
Okay, 256. 256 minus 2. That will give us
254.
254. So that's how you see that they arrive at this 254 here. So that's how they arrive at the 254 here. What if you want to find how many number of B hosts you can see in B and you don't want to be cramming all this thing for your head? We're still going to be using the same formula, which is 2 raised to power y minus 2. Okay, so if I bring out a class B subnet mask, class B subnet mask is 255.255.0/.0. So it means that we're going to have like an 16 0, which is 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 8 will be 16. So here now means that when we come back here will be 2 raised to power 16 minus 2. Please, someone help me to check 2 raised to power 16 minus 2. 2 raised to power 16 minus 2.
So 2 raised to power 16 is 65,536.
So minus 2, it will give you 65,534. So that's how you get the number of hosts. So you can use that shortest formula to know how many number of hosts. And if you can actually put it offhand, that one is actually great. So all those guys, how you know the number of hosts in each classes of the address. Okay, so what's the function of a subnet mask? Here says a subnet mask tells a computer or other network devices what portion of the IP address is used to represent the network and what part is used to represent host or other computer on the network. This subnet mask we are seeing like this, what is the function of the subnet mask? This subnet mask here is going to tell a computer which portion of address is used to represent a network, which portion address is used to represent a host. How? For example, if I bring something like this outside, I'm going to delete all these things. So if I bring a class A subnet mask, which is 255.0.0.0, that is for class A. If I bring class B subnet mask is 255.255.0.0, that is for class B. If I bring class C subnet mask is 255.255.255.0. So let's now assume that inside a class A subnet mask, we have an IP address, and that IP address is 100.0.0.0. Maybe that's an IP address. Maybe in the class B as well, we have an IP address that's 128.100.0.0. In class C as well, if I have an IP address of 192.168.100.0, what does it mean? Anytime that I see an IP and I see the subnet mask, this subnet mask here going to let me know which portion is for the network and which portion is for the host. So anytime you see this IP, it means that this 100 here is a network portion, because this 100 falls under the 255 you see here. So that's the network portion. It means that this IP must be constant on all the addresses on the system. You must find this 100 on all the addresses. But this 30 here can now be changing to any other number. What of class B? Anytime you see IP inside class B with the subnet mask of 255.255.0.0, these two 255 here tell you that the two octets on that IP is meant for network address. That one cannot change. But the only two can now be changes to any other number. So it means that any IP, any devices we are assigning the IP address to, 128.100 must be present on their own IP. But a zero can now be any number, because this zero is for the host, 128.100 is for the network. What for the class C? If you see this class C, you're going to see that we have like 3255. This 3255 means that the three blocks of this address is meant for the network address. But the last one, that is 0, is meant for the host. It means that any devices using this IP, this 3 block must be present on all their IP. But a 0 can now be changing to any number. So that's the function of that particular subnet mask. Subnet mask going to let you know which portion is meant for the network IP and which portion is meant for the host IP. So next thing here is the 127 that they omit inside that particular ranges of the address. So what is the function of this 127? Here says 127.0.0.0 is a loopback subnet. The IP address 127.0.0.1 is called a loopback address. Packets sent to this address never reach the network but are looped through the network interface card LAN adapter only. So what is the function of this address? This address here is meant for some test on your network. Anytime you want to test if your interface card, your network interface card is working perfectly, or your network to the TCP IP on your port is working perfectly, you make use of a 127 address. So 127 address is to check if your network adapter on your system are available. How do you check? So if you open your terminal on your system and you type ping 127.0.0.1, you hit the enter key. So anytime you are getting reply, it means that everything is working perfect on your system. But if you are not getting reply, it means that there's some errors on that particular system. So me getting reply means that all the network card on my system is working perfectly and they are available. So that's the function of that particular address. So here says this can be used for diagnostic purposes to verify that the internet path through the TCP/IP protocol is working. So anytime you ping that address and you are not getting reply, it means that there is a issue on it. Okay. So here says classes of IPv4 addresses continue. There's what we call an RFC, which is request for comment. RFC, what are these guys do? These guys here are the one that they give us a private IP address that we use on our LAN. Do you see all these classes of IP address? All these classes of IP address are actually a public IP. They are a public IP. It means that before anyone can use all the ranges of this IP, they need to get it from ISP. So what's the function of RFC? RFC here are just the bodies that they give us a private IP address that we can use within our LAN. So they are the one that they give us a private IP that we can use within our LAN. So what are the ranges? So in each classes of IP, they give us a free IP that we can be used without paying any ISP money about it. So they now say in class A, anytime we see an IP started from 10.0.0.0 ended at 10.255.255.255, that IP are free. You can use all those IP freely without paying for the IP. What about class B? But anytime you go beyond this range, maybe you're now using 11, 12, all those guys, it needs to pay for it before you can use it. So next one here is a class B, 172.16.0.0, 172.31255.255. So anytime you use any ranges of IP from this range, all those IP are free. You don't need to pay a dime for it before you can use it. What about for C? 192.168.0.0 ended at 192.168.255.255. All those IP are free IP. When I'm talking about free IP, it means that the IP can only be used within your LAN, which are the IP falls under a private IP. As I already explained to you, private IP cannot go to the internet. You cannot use a private IP to browse the internet. You can only use the private IP to communicate within your internal LAN. So anytime you need a IP for your LAN, you can come to the ranges of this RFC address and assign it to your system. And all those systems will be able to communicate within the LAN. So here says these IP addresses are only used for internal communication only, which is LAN, and are not allowed on the internet. All ISP has to block these addresses from getting to the internet. So anytime you are using a private IP address, which are these ranges, all these ranges of this private IP address can only work inside your LAN. You cannot use this IP to communicate to the internet because all the ISP are already blocked all these IP from getting to the internet. So when you're talking about this IPv4 address, there is a features that we call APIPA. What does APIPA means? APIPA stands from a automatic private internet protocol address. Automatic private internet protocol address. What does this APIPA means and how can you get APIPA? So before I talk about it, these APIPA addresses fall inside class B IP and these are the ranges of the APIPA address. So anytime you are seeing an IP 169.254.0.1 ended at 169.254.255.254, all these IP here are the IP given to you by APIPA. So how can you get APIPA address? Here says automatic private IP addresses called APIPA is a feature in operating systems such as Windows that enable computer to automatically self-configure an IP address and subnet mask when their DHCP server is not reachable. Okay, so how do you get APIPA address? I already explained to you that there's a two-way you assign IP address to your system. Either you are using static, which means that you are the one giving the system, or you are using DHCP. And who is giving you IP on DHCP? Who is giving you IP on dynamic is DHCP server. So either you are using static or you are using dynamic. Anytime you are getting IP on static, it means that you are yourself, you are the one that assigned the IP. But anytime you are getting IP on dynamic, it's given to you by your DHCP server. But anytime your DHCP server is not available, maybe the DHCP server that's supposed to give you IP on an automatic way, it is not available, your system going to assign IP address to itself. So the IP address that your system give itself, that IP is what we call APIPA. So anytime your system configure itself IP, that IP is what we know as an APIPA. What are the other scenarios that you can get APIPA? Anytime we have a duplicate IP address on the network, maybe I have computer A and I have computer B. Anytime I'm assigning a single IP to both two computers, the other computer will be getting APIPA because that single IP will be only used by only one computer, and the other computer will be ending up configuring itself IP, which is what we call an APIPA. So those are the ways that you can get APIPA on the network, and any system get APIPA on the network cannot communicate to anybody on the network. So any system that is getting IP address on APIPA, no way the system will be able to communicate until you solve the problem. So just put it in mind, when we're talking about APIPA, how can you get APIPA on your system? Is either when your DHCP server is unreachable or you have a duplicate address on the network. All right, I'm hearing you.
So my question is, if the system gives itself an APIPA,
Okay.
right? And the job of the APIPA is to intermediate
I'm hearing you, please.
If it does that, why is it that they are not communicating since the APIPA has intervened in the duplicate IP?
Okay, like what I explained to you earlier, I explained to you that when we're talking about networking aspects, IP address, we have what we call a network. Anytime we have a network, for example, let me bring this thing outside. If I bring my notepad, if we have a network called 192.168.100.0, how many IP can we see inside this network I place here? My question is that, please, before I answer your own.
Say again, please.
Inside this network, 192.168.100.0, how many IP address can we see inside the network?
I think 64,000.
I explained this to you when we talking about the IP address.
In the
Okay,
table.
so
Yeah,
don't let me waste time. Actually, inside this network, we can see 254 IP address. We can see 254 IP address. It means that the first IP will start from 192.168.100.1. That's the first IP. Second IP will be 192.168.100.2. That's the second IP. Third IP will be 192.168.100.3. So that's how you'll be having the IP. So let's now assume that I have like 5 computers on the network. So when I have 5 computers, the first computer is getting 192.168.100.1. Second computer getting 192.168.100.2. Third computer getting 192.168.100.3. If the fourth computer getting 192.168.100.4, Let's now assume that the last computer now getting 169.100.200.254.1, which is APIPA. If another IP of the last system is this guy cannot communicate to anyone on that network because the IP is different for the IP that the other one is using. So any system on the same network are the one that they are able to communicate. System on different network cannot communicate. So anytime we have 169 is different from 192. So it means that they cannot communicate. But do you see this four system? They are on the same network. When you see 192.168.100, 192.168.100, 192.168.100, it means that the four of them belongs to the same network. Those four can communicate. But the last system, this network of this guy, this 169.100 or 254 is actually different from 192.168.100. So that's the reason why any system getting APIPA cannot communicate to any system on the network.
Yeah, then what is the reason for the APIPA if it's actually, if the network, if a system loses access to the server or to the network, and then the system automatically assigns itself an IP called APIPA? What then is the function of that APIPA? Why don't you just leave it blank until the network restores?
No, normal any system on the network, before system can join to network, system need IP. No matter how, the system need an IP. So that's the reason why anytime the system see that the network administrator does not assign the IP or the DHCP does not assign the IP, the system going to give itself, but the system doesn't know the network that you are using. So it means that anytime we have like a four system getting APIPA on the network, that four system getting APIPA, they will be able to communicate to themselves. The first system getting APIPA will be able to communicate, but they are not going to be able to communicate to other systems. So is a policy on the network that any system on the network must ask its own IP. So when the system realize that the network administrator did not assign IP or the DHCP is not giving the system IP, the system will automatically give itself IP just to stay alive. That's the rules. It's not maybe the IP will allow it to communicate. No.
Okay, so sorry for the lot of
Yeah,
questions. I
no
just
problem.
want
No
to
problem.
understand. So that simply means that, let's say there is 10 systems here and 4 is connected to the network for whatever reason. Maybe the remaining 6 is not connected. So the systems will automatically assign themselves an APIPA. And then the APIPA will then help. So the APIPA is more like an identifier for the systems that are not connected, that have lost connection to the network. Is that?
No, anytime you see any system connected to a network and is getting APIPA, anytime you see APIPA inside the system, it's telling you that there's a problem with the IP on that system. And I already explained a scenario that you can get APIPA. How can a system get APIPA? That means that there is a duplicate of address. Maybe the IP that the system is supposed to get, another system is using it. That's when the system can get APIPA. Or anytime the DHCP server is not available, maybe there's a problem with the server and the DHCP server is not working, the system can give itself APIPA. But anytime you see that you see 169, the best thing is for you to go there, assign the right IP address to the system so that the system will be able to communicate. But anytime all those things is having issue, the system cannot just leave itself like that. It needs to give itself IP. That is the policy. And when the system giving itself IP, the IP that we're going to be choosing is a APIPA, which is the IP that the system can assign to its own. But anytime we have like 3 system that they are getting IP on APIPA, all those 3 systems getting APIPA, they will be able to communicate. But the right thing is for you as a network administrator to solve it so that they will be able to communicate to the entire network and everything will be working perfectly.
Thank you very much.
Welcome. Okay, any other question?
Yes. So how can all the IPs, the administrator will view all the IPs of the system on the network?
Okay, there's a tools that we use. That tools here is called an advanced IP scanner. So if I connected like thousands of employees to a network, if I launch the tools, let me show you. It's like I have the tools on my system. I'm coming. Advanced IP scanner. That's the name of that tools. Okay, I don't have it again. If you go online, so I'm just going to show you advanced IP scanner. This is the tools. These tools here, you can use it, but I'm not going to be downloading it now. These tools here, you can use it to scan your network. When I'm using these tools to scan my network, it's going to be showing me everybody on that network and the IP address that each of them are using. So that's how you can see it. Okay,
Yeah, thank you.
so we are through with the classes of IP. But there's another thing I want to explain to you before we move into the next thing. When you're talking about this IP address are 32-bit address. 32-bit address. When we're talking about 32-bit address, what does that mean? If I have an IP address and the IP is 192.168.100.8, that is an IP. So when we're now talking about 32-bit, 32-bit means that this IP contains of 32-bit. How? Because this IP here has 4 blocks. Anytime you are hearing about IPv4, IPv4 address has 4 blocks. The first block is this, which is the dot one. The second block is this, which is the second dot. The third block is the third block. And this is the last block. So IPv4 contains of a 4 block, and each block contains 8 bits. So each block contains 8 bits. It means that under this guy we're going to have 8 bits. Under this guy we're going to have 8 bits. Under this guy we're going to have 8 bits, and under this guy we're going to have 8 bits. So the approximation of all these bits is what we call 32 bits. This guy is going to give us 32 bits. Going to give us 32. So anytime you are hearing about IPv4 address, IPv4 address contain 32 bits because each block inside this IPv4 has 8 bits. What does bit mean? Anytime you are hearing a bit can be in zero. Is either you see 1, 2, 3, 4, 5, 6, 7, 8, or you see 1, 2, 3, 4, 5, 6, 7, 8, or you see 1 mixed with 0. That is what a bit is. Anytime you are hearing a bit, that is what we call a bit. It means that anytime you find a binary for 192, is either you get 0 or you get 1 or you get 0 mixed with 1, but it will end at 8. That's why we have 8 bits. What if you find binary for 168? You're going to see another 8 bits. If you find binary for 100, you see another 8 bits, another 8 bits. So calculation of all those things give you 32 bits. So put it in mind, IPv4 address is a 32-bit address. And in each IPv4, they have 4 blocks. Each block has 8 bits. But for IPv6 here, it has like 128 bits. IPv6 has 128 bits. IPv4 here has 32 bits. So let's continue. Next thing here is to talk about TCP IP layers.